Topic 10 in engineering data analysis. Simple linear regression and correlation. An empirical model is based only on data and is used to predict, not explain, a system. An empirical model consists of a function that captures the trend of the data. The graph of the function goes through the data points approximately. The least squares method is a statistical procedure to find the best fit for a set of data points by minimizing the sum of the offset of residual of the points of the plotted curve. Empirical modeling refers to any kind of modeling based on empirical observation rather than on mathematically describable relationship of the system model. Linear regression. Linear regression is the simplest and commonly used statistical method for prediction studies. It is concerned with finding an equation that uses the known values of one or more variables. It is called the independent or predictor variables. To estimate the unknown value of quantitative variable, it is called the dependent or criterion. It is the prediction when a variable y is dependent on the second variable x. It is based on the regression equation of a given data. In the statistic linear regression, it is a linear approach for modeling the relationship between the scalar response and one or more explanatory variables. After a scalar plot, it is constructed and the value of correlation coefficient is deemed to be significant. Then, the equation of the regression line is determined. The regression line is the data's line to be fit. The closer the points fit the regression line, the higher the absolute value of r, and the closer it will be to positive 1 or to negative 1. The case of one explanatory variable is called the simple linear regression. For more than one, the process is called the multiple linear regression. Okay, let's proceed to formula for regression line. Y prime is equals to a plus bx. V is equals to the sum of square xy over sum of square xx, and a equals to y bar minus b x bar, where x bar mean of x, y bar minus b x bar. Summation of sum of square xy is equals to the summation of xy minus summation of x multiplied by summation of y divided by n. And the other one is the sum of square xx is equals to the summation of x square minus summation of x square divided by n. Note that the round of the values a and b are in 3 decimal places. The characteristic of the regression line. When b is greater than 0, y increases as x increases. In this case, we say that y is directly or positively related to x. While when b is lesser to 0, the y decrease as x increase. In this case, we say that y is inversely or negatively related to x. When b is equals to 0, y is constant and it is equal to y, negative intercept. And this implies that there is no change in y whatever x value is. So okay, let's proceed to example. A CE professor at Isabela State University wants to see how strong the relationship is between the student score on the test and student grade point average. The data obtained from the sample follow. The test score x, the given number are 100, 70, 97, 100, 88, 90, 79, and 100, while on the GPA y, 2.1, 2.4, 3.2, 2.7, 2.2, 2.3, 3.8, and 3.4. So now, let's proceed to the solution. In order for us to answer the xy, we need to multiply the x and y, which is in the subject 1, 100 times 2.1 is equals to 210. 70 times 2.4 is equals to 168. 97 times 3.2 is equals to 310.4. 100 times 2.7 is equals to 270. 88 times 2.2 is equals to 193.6. 90 times 2.3 is equals to 207. 79 times 3.8 is equals to 300.2. And 100 times 3.4 is equals to 340. In the sum is just add all the x, y, xy, and the answer is 724, 22.1, and 1999.2. The x square, just square the x. 100 square is equals to 10,000. 70 square is equals to 4,900. 27 square is equals to 9,409. 100 square is equals to 10,000. 88 square is equals to 7,744. 90 square is equals to 8,100. 79 square is equals to 6,241. 100 square is equals to 10,000. 724 is equals to 66,394. And now let's proceed to y square. So what I do in x, just square it. 2.1 square equals to 4.41. 2.4 is equals to 5.76. 3.2 square is equals to 10.24. 2.7 square is equal to 7.29. 2.2 square is equals to 4.84. 2.3 square is equals to 5.28. 3.8 square is equals to 14.44. 3.4 square is equals to 56, and the sum is 63.83. So let's proceed. Sum of square xy is equals to summation of xy minus summation of x multiplied by summation of y divided by n, and it is equals to 1999.2 minus 724 multiplied by 22.1 divided by 8, and it is equals to negative 0.85. Xx is equals to summation of x square minus summation of x square divided by n, and it is equals to 66,394 minus 66,394 divided by 8, and it is equals to 88,094.75. Okay, let's proceed to correlation. Scatter plot is a graph of ordered pair xy of numbers consisting of independent variable x and a dependent variable y. The independent variable is the variable that can be controlled or manipulated. The dependent variable is the variable that cannot be controlled or manipulated. The independent is plotted on the horizontal axis and the dependent variable on the vertical axis. The purpose of this graph is to determine the nature of relationship between the variables. The relationship may be positive linear, negative linear, curvilinear, or no discernible relationship. Correlation. It is a statistical method used to determine if there is a relationship between variables and the strength of the relationship. Pearson correlation coefficient. The degree of linear association relationship between the two variables at this of interval scale. It is measured by a correlation coefficient denoted by R. It is sometimes called Pearson correlation coefficient, Pearson product moment correlation coefficient. The honor of its developer, the formula is R is equals to n summation of xy minus summation of x summation of y divided by square root of n summation of x square minus summation of x square multiplied by n summation of y square minus summation of y square. Formula n is equals to the number of pairs of score. Summation of x is the sum of x scores. Summation of x squared sum of squared of x scores. Summation of xy is equals to the sum of the product of paired scores. Summation of y is the sum of y scores, and the summation of y squared sum of squared y scores. Interpretation. Positive negative 1.0 is equals to the perfect positive negative correlation, while on the positive negative 0.80 to 0.99 is very strong positive negative correlation. Positive negative 0.60 to 0.79 is strong positive negative correlation, while on positive negative 0.40 to 0.59 is the moderate positive negative correlation. In positive negative 0.20 to 0.39 is weak positive negative correlation. And positive negative 0.01 to 0.19 is very weak positive negative correlation, and in zero point 0.0 is, there is no correlation. This is the example that I tackled a while ago, so let's skip it. And the summation of x is equals to 724. Summation of y is equals to 22.1. Summation of xy is equals to 1999.2. Summation of x squared is equals to 66,394, while on summation of y squared is equals to 63.83, and the n is 8. And this is the formula that I've been tackled a while ago. So let's just distribute the number. R is equals to 8 multiplied by 1999.2 minus 724 multiplied by 22.1 divided by square root of 8, 66,394 minus 724 square multiplied by 8, 63.83 minus 22.1 square. And it is equals to negative 6.8 divided by square root of 6,976 multiplied by 22.23. The R is equals to negative 6.8 divided by 393.798, and the R is equals to negative 0.017. And the 0.017 is the correlation coefficient suggests a weak negative relationship between the test score and the grade point average. And that's all for the chapter 10.